Welcome to the Age Reversing Blueprint podcast, where we discuss tools and tips to help you reverse your age naturally.
Research is focused on, okay, what is actually causing the root cause of NAD decline? Because if it's so important, then, why is it declining in the body? The main issue is that our natural pathway for NAD production in the cell, which is called the salvage pathway, seems to decline with age. And the reason that this happens is that a key enzyme within this pathway called NAMPT declines. And again, this has been well studied and well documented. And the issue with the decline in this enzyme is it's the enzyme that our cells really rely on for not only making NAD, but actually recycling it. So what many people don't realize is that the vast majority of our NAD that is produced when we are young is actually by recycling. So every time our NAD is used in the cells, when it's used by DNA repair enzymes, for example, or by longevity proteins such as the sirtuins, it actually gets split apart and broken down into its building blocks. And one of the main things that it gets broken down to is a compound called nicotinamide. Now, in young cells, what happens is this salvage pathway with this key enzyme literally will scoop up this nicotinamide and recycle it straight back into fresh NAD again. And when you think about it, it's kind of like the perfect design, because really we don't want our cells to run out of NAD. So this design means that as consumption of NAD goes up, recycling also goes up to restore what is being used. So it's not great in our cells as we become older that this enzyme seems to become turned down for various reasons.
Our guest here, Dr. Nichola Conlon. She's a molecular biologist specializing in the study of cellular aging. After a career in drug development, Dr. Nichola founded the Nichola Laboratories to deliver disruptive innovation in the field of aging, rejuvenation, and health span. She has a passion for sharing her latest science and accomplished speaker, and has a skill in translating the advanced science to help educate the support of the wider population, encouraging people to age well and achieve their optimal life experiences. Perfect for our podcast today. Thank you so much, Nichola, for being here today.
Thank you so much for inviting me. I'm excited to have a great chat today.
Yes, excellent. And so what I like to do is I usually go back and figure out, why did you get into the area that you did? But I'm actually want to fast track that in terms of how did you go from drug development to more of a, I would imagine, a holistic or alternative route. Maybe tell us about how that came about.
Yeah, that's a great question because it's quite unusual, I guess. So as you mentioned, my background was in drug development. I originally worked in cancer therapy, and then one day I got moved on to looking at aging, which at the time, we're talking about a decade ago now, was quite a new thing. And even I was like, okay, drugs, like aging, like how does this all fit together? But what we know is that there was a huge change in the science surrounding aging, and there was a lot of evidence coming out that we could actually reverse aging at the cellular level. And we know that aging is our biggest risk factor for every disease, every major disease that drugs companies are trying to treat or to cure. So the idea was, if we can slow aging at the cellular level even just a little bit, will it actually reduce our risk or our onset of age-related disease? So I was really fortunate enough to be able to basically travel all over the world, meeting all of the people who were experts in the longevity field, all the conferences, and really learning what this science was all about and how we could incorporate it into drug development. So that was exciting. But there were two things that really annoyed me in the world of drug development. The first was that it takes a very, very long time to get anything from the research labs, really initial drug development, early stage, out into actually being a medicine that somebody can actually take and benefit from. You know, you're looking at about 10 to 15 years, hundreds of millions of pounds to do this. So, you know, I was looking at all this cool science and thinking, okay, this is great, but it's going to take a long time before it gets to benefit anyone. The second really annoying thing was that part of my role was to, you know, we'd send a load of molecules to the lab to be tested. We'd then get a spreadsheet back, which was like, okay, these things work really, really well at the top, and these things don't work at all at the bottom. And quite often, some of the things that were really potent and had really high efficacy were not drug molecules. They were natural molecules, things that were already very well known, things that were already approved as supplements that worked brilliantly. But unfortunately, drugs companies aren't interested in them because they can't patent them. And if a company can't patent it, it can't own it. It therefore won't put all the money into development. So often we would go through the list and go to something that worked half as well. And that would be the thing that got put into drug development. So I was like, okay, this is commercially makes sense, but ethically is just not right. And this shows us that there are things that are out there already that if they had the right research and testing, that we could actually have some pretty good, you know, things, molecules that could actually help people right now. So in 2017, I left that world. I founded my own company, Nichola Laboratories, and the whole mission behind what we do is to do exactly the same science that we did in drug development, exactly the same testing, although not to the degree that they do in drug development, but basically get that science out there and test the molecules that weren't drugs, the things that we know we can get into consumer products, and out to people so that they can benefit from them now. So that's kind of a decade summed up. But I think, you know, the real mission behind, you know, a lot of people said to me, oh my goodness, you are leaving your very credible job in drug development to start a supplement company, and supplements have a terrible reputation. Like, what are you doing? And I always had to keep reminding people that actually your body has no idea what is a drug or what is a supplement, what is a nutrient. It's, you know, regulatory authorities that put them on lists. But actually a lot of the other molecules that aren't drugs have just as equally powerful physiological effect in the body. And unfortunately, we've been trained not to think that, and to think that only a drug can help. And that is absolutely not the case.
Yeah, no, it's an excellent preview of review of what you've done. And I love that you brought the same approach in terms of validating it and setting up studies. And I know you've created a study, which I want to get into shortly. But as far as you mentioned that you noticed that it was possible to reverse your biological age. Maybe discuss what that means to the layperson in terms of the biomarkers that are correlated with age, and what that actually means as far as reversing it and what those are.
Yeah, absolutely. So what we know now as scientists are that there are key things that go wrong in our cells with age. Now, famously within the scientific community, these are referred to as the hallmarks of aging. And there's now known to be 12 hallmarks of aging. So essentially, these are 12 critical processes that seem to start to become dysfunctional as we get older. And anything you can do to kind of fix those processes seems to reverse the aging process. Now, a really interesting way of measuring this is to look at your biological age. So you have your chronological age, which is the age that you have basically existed on this planet. You know, it's to do with when you were born, your birth certificate, and that's your chronological age. There's nothing you can do about that. It is what it is. The biological age, on the other hand, is the age at which your cells are functioning on the inside. So this can be measured. You can literally, take a sample of your cells, different types of cells, and you can look at what the biological rate of aging is in these cells. And what is known is that actually your biological age is a much better predictor of your future health than your chronological age. Because what we found is that quite often people's chronological age and biological age don't always match up. And what I mean by this is, for example, somebody may have a chronological age, they may be 50, but if you look at their biological age of their cells, they may look more like 60. And this is obviously bad because it shows they're aging at a faster rate than they should be. Alternatively, you can go the other way and, someone that's age 50 could have a biological age of 40, and that's good because they've got a lower rate of cellular aging in their cells. So this has been a really interesting development, and it's allowed us as scientists to be able to look at how different interventions, different molecules, different drugs, things like that actually can reverse our aging process by having this way of measuring aging. Because obviously, when you're looking at aging and trials and things like that, you can't, wait for a person to age and see, and measure how long it takes them to become old and frail. That's just, something that's not possible. So this is a really good biomarker way of being able to measure the aging process.
Right. And I think that what really, brought the research together, maybe you can agree on this or not, is the fact that it's tied into outcomes, right? I mean, as far as it's one thing to say what your chronological age and biological age is, but does it relate to all-cause mortality and so forth? So maybe speak about that briefly, if you will, of what risk factors or how they're tying in or what they're benchmarking the biological age to the outcomes are. Does that make sense?
So I think, this whole area is really new. So there are still a lot of ongoing studies looking at, how is your biological age linking to more of the clinical factors and things like that. There's multiple different ways to be able to measure biological age as well. And what a lot of the scientists behind this research are doing are looking at more longitudinal studies of measuring people's biological age and then looking at their health outcomes. A really interesting one that was done with one type of biological age testing, which looks at something called Glycan age, was looking at studies in twins. So these are people that are biologically, genetically identical. So any difference in biological age is therefore down to their lifestyle, and look at how lifestyle in different diseases and, is actually impacting a twin's biological age. So I think this is still a huge area of research. I think there's still a lot of argument over, how much is the biological age correlating to health span and disease and things like that. But every day now there's more and more evidence coming out that your biological age is a very good predictor of your future health.
Right. No, I appreciate that. And I think it's really a paradigm shift in the way health is headed towards being preventative and understanding better markers, because so many people that are exhausted and tired, Nichola, are being told that their blood chemistries look normal and that they don't feel normal and they're not getting the true answer. And it's sort of like they have to wait before they get more sick before some of these less sensitive or specific tests are coming up with identifiable risk factors. When I always use the analogy, it's like a grade school teacher telling their student, you're not getting low enough grades on your report card yet before we can implement any strategies. We have to wait before you're getting an F or a D- before we can do anything. So I guess the transition and the question would be NAD and NAD plus, and where does that all fit into the age-related changes, and maybe give us some insight on that.
Yeah, I think what you've just said, is something that I'm very passionate about as well. A lot of healthcare is actually sick care. It isn't healthcare, it's not preventative. And I think that's something that really does have to change. When it comes to aging, as I've mentioned, age is our biggest risk factor for every major disease. It's getting older is the worst thing you can do for your health. It's worse than a lot of the other things that we are told are bad for us. But people, unfortunately, don't register it like that. So what we know is that everything to do with aging starts at the cellular level. So despite the fact that traditionally a lot of people think of aging on the surface and treat it at a surface level, ultimately it starts at the cellular level. Therefore, anything that you can do to improve your cellular health is only going to have a beneficial outcome when it comes to aging. And this is where something like NAD comes in, because we know that NAD is naturally found in every single cell in our body. And it's very important for cellular health because it's involved in hundreds of different reactions to begin with, but it's probably most famous for two critical cellular functions, and that is cellular energy production, so helping to convert all the food we eat into the energy that our cells can use to have a healthy cellular function. And the second thing it's important for is for switching on a lot of cellular maintenance and repair processes. So NAD seems to act as a signal to keep our cellular maintenance and repair pathways turned on. So we know that NAD seems to be linked to aging because it actually declines with age. So when you're young, you seem to have higher levels of NAD. Then as you get older, these levels decline. And when NAD goes down, you get less energy production, you get less repair and maintenance within the cells, and also a whole host of hundreds of other processes that are relying on NAD that start to get turned down. And this can accumulate as cellular damage. And this is, ultimately results in a lot of the signs and symptoms that we experience as aging. So scientists said, okay, if we've got this molecule that seems to be really important, and when it declines, it causes all these problems, then why don't we just not let it decline? Why don't we top it back up to useful levels, or not let it decline in the first place? And to cut a very long story short, what hundreds of peer-reviewed papers have now demonstrated is that if you boost NAD levels within the cells, you switch on a whole host of beneficial pathways that protect cellular health. So NAD has been found to be one of the only things that can actually impact every single hallmark of aging. So because of that, there's a lot of excitement around the potential for NAD to restore cellular health and how that can protect us from some of the negative consequences of the aging process.
No, that's a great answer. I'd be interested to know how your research design went, because I know it's just not as straightforward as it falls or it depletes on its own. There's reasons for it to be depleted. And I would imagine it's not just a take it, set it, and forget it type mechanism. So maybe get us some insight on your research design and what you found, and share that with our audience.
Yeah. Well, first of all, just to mention, whenever I do a presentation talking about NAD decline, I always show a graph. And the graph I show doesn't just go straight down, it's bumpy. And it's lots of peaks and troughs, and it's a bit all over the place. And the reason for this is because everyone's slightly different. So we know in general that NAD declines, but in some people it declines a lot faster, and some people it declines slower. In some tissues it's faster, in some tissues it's slower. In disease states, it can accelerate NAD decline. So it's not a straight down. Everyone is slightly different. And that's obviously because we're all individuals. We all have different genetic makeup and SNPs and different enzymes that can affect it. But as a general rule, it does decline. So a lot of research is focused on, okay, what is actually causing the root cause of NAD decline? Because if it's so important, then, why is it declining in the body? And what's been found is that there's not a single cause of NAD decline, but actually a couple of things within our NAD network within the cell that seem to become dysfunctional. The main issue is that our natural pathway for NAD production in the cell, which is called the salvage pathway, seems to decline with age. And the reason that this happens is that a key enzyme within this pathway called NAMPT declines. And again, this has been well studied and well documented. And the issue with the decline in this enzyme is it's the enzyme that our cells really rely on for not only making NAD, but actually recycling it. So what many people don't realize is that the vast majority of our NAD that is produced when we are young is actually by recycling. So every time our NAD is used in the cells, when it's used by DNA repair enzymes, for example, or by longevity proteins such as the sirtuins, it actually gets split apart and broken down into its building blocks. And one of the main things that it gets broken down to is a compound called nicotinamide. Now, in young cells, what happens is this salvage pathway with this key enzyme literally will scoop up this nicotinamide and recycle it straight back into fresh NAD again. And when you think about it, it's kind of like the perfect design, because really we don't want our cells to run out of NAD. So this design means that as consumption of NAD goes up, recycling also goes up to restore what is being used. So it's not great in our cells as we become older that this enzyme seems to become turned down for various reasons. The other thing that's been found to really reduce NAD levels is that more NAD is actually used in our cells as we get older. And this is largely due to chronic low-grade inflammation, which we know is a major issue as we get older. We know that inflammation causes increased expression of a protein called CD38, which is on our cell membranes, which degrades NAD. So if you put those two things together, it's kind of like the perfect storm. Not only is our cells using more NAD, but actually they've lost the ability to recycle the breakdown products and actually restore it. So, you've got this perfect situation for huge NAD decline as you get older. So what we were looking at was, okay, how can we restore NAD, but how can we do that by actually fixing these issues? Because unfortunately, a lot of the sort of ways that people are trying to restore their NADs and things like precursors or IV drips or anything like that are like ignoring the reason of why it's declined. And what we wanted to do was actually design something that would actually fix the root causes that are causing the NAD decline in the first place.
So what was it that you did? You're leaving me on a cliffhanger here.
Sorry. So we designed a dietary supplement, and in the supplement, not only do we have a precursor in there, which is the building blocks that the body uses to make NAD, but it has ingredients in there which actually restore levels of that key enzyme. So they restore that salvage pathway recycling. There are also ingredients in there that will inhibit CD38 to reduce the wastage of NAD. And we've also got ingredients in there which actually prevent the methylation and excretion of some of the NAD precursors, which I haven't discussed, but is an issue. As we get older, we see a reduction in methyl groups because the cell is actually using them and wasting them, trying to get rid of the buildup of some of these precursors because it can't actually recycle them. So again, we have ingredients in there that are designed to inhibit that process. So everything about it is basically how do we look at the problem as a whole and actually fix the issues that are causing NAD decline. And as we mentioned, my background's in drug development. And when I started the company, I said, a key sort of mission of ours is to bring more credibility to the supplement industry through testing. So we actually did a double-blinded, placebo-controlled crossover study, which is, as far as clinical trials go, is a gold standard to test, did our supplement actually work? And we measured a lot of different biomarkers within this study. Obviously, the key the key thing to measure was NAD. Does it boost NAD levels? And we found that it does. So after 28 days of supplementation, we see a significant increase in NAD. Actually, after 7 days, the increase is significant. So we know that it acts pretty quickly. We also measured levels of this key salvage pathway enzyme in the participants, and demonstrated again after 28 days, we actually had switched back on and boosted levels of this key enzyme. And that's the first human study to demonstrate that a supplement can be used to actually switch back on and fix one of the root causes of NAD decline. So yeah, we measured a lot of other things as well. I don't know if you want me to go into all of them or if you have any questions.
Hi, I hope you're enjoying our interview so far. Today's show is brought to you by Nichola Time. This is the NAD product that we are talking about. Make sure you check out our show notes and click on the link. And if you use Dr. Joel 20, that's all capital DRJOEL 20, you will get 20% on your first order. That's excellent. I'm curious to know, you mentioned earlier, and now we talk about a couple tests. We're talking about potentially measuring the CD38 levels as a marker of, is that decreasing or increasing, or where is it in the beginning and the end? The intracellular NAD, I'm sure, looking at potentially that particular enzyme that helps to recycle that NAD. And then you mentioned the Glycan test. I'm not sure, is that the same thing as a DNA methylation test, or can you tell me a little bit about that?
Yeah, slightly different. So this was something we actually included in our trial to measure biological age. So the way the Glycan age test works is it looks at our IgG cells, so our immune cells, and it measures the levels of glycans, which are small sugar molecules that are found to be attached to the surface of these cells. And what is found is that as we get older, the pattern of these glycans changes. So if you're to look at a young person's cells, they'll have a particular pattern. And if you look at a much older person's cells, they'll have a very different pattern. And you can see across all the sort of years or decades that there's a very predictable shift in the pattern of these sugar molecules, and that can be used to look at the biological age of the cells. So that is how that test works. We did it in our trial, and what we found was that in 28 days, over the course of that time and over the entire set of participants, we on average reduced biological age by 1.26 years, and that was in 28 days. So we were pretty pleased with that. And I think it's demonstrating the power of NAD at the cellular level, excuse me. And how it can be used to actually help address some of the issues of aging at the cellular level. Sorry.
That's okay. No, that's fine. So, all right. So that's sort of like the glycation process and the browning and understanding. Okay, gotcha. So curious to know then, before I ask you a little more of a technical question, what was the dosing of the actual precursors, or what I mean, was it your product that you're,
Yeah. So the supplement, so it was the actual finished supplement that was used, which is, you've got to be careful as well when supplement companies say they've done clinical testing, because often what it'll be is it'll be clinical testing of one very small component of that supplement, often not at the same dose that is used in the supplement. So what we did was we give all the participants, they were given the actual final finished, as you buy it off the shelf supplement. The supplement is actually 6 capsules per day, which again seems like quite a lot, but that is from our pilot study, the amounts that we know work. There's no fillers or anything like that in there. It is all active ingredient, because that's the concentrations that work. And the participants took the capsules on a daily basis. And as far as the blood sampling and things like that, they had baseline bloods done. They had a blood sample done at the same time, exactly the same time every week. to ensure continuity, because what a lot of people again don't realize is that NAD fluctuates throughout the day, and a lot of trials that have been done on sampling NAD don't take this into account. And you can measure your NAD at 2 different times of the day and it will be very different. So it's very important when doing any trials that you have the continuity with testing times.
Right. Gotcha. So with your company, obviously it's the product that you're promoting that you used in the clinical trial. Are you also doing, and I saw it somewhere and I didn't see it before I got on, so I apologize. Are you also doing the intracellular NAD or the glycan testing as a retail product, or more for research stuff?
No, so we do it as for research. So NAD itself is a bit of a tricky thing to measure, and we don't provide that as a service. All of our NAD testing was done in academic labs. NAD is very unstable, so it's got to be processed very quickly to be able to measure it accurately. So this means it's not something that's available to many consumers to measure. So what we wanted to do was put a test within our clinical trial that was accessible to consumers, so that they could do some sort of test at home to, see that their supplement is actually having an effect. Because a lot of people say, well, how do I know it's doing anything? So we actually we don't sell the kits or anything, but we promote a lot of our customers to go and do a test and say, in our clinical trial, we use this kit. It was used in our trial, but this is something that is commercially available for you to go and independently buy yourself. And if you want to know it's working, we're so confident in our product, go and test it. So yeah, we don't sell them or do it as a service, but we promote our customers to test it themselves.
Yeah, I find that more and more sophisticated end users are wanting to know, because they had been that person that went to the doctor and was told that something isn't working, and they want to become more their own study of one. So the question I have now is a little more complicated, but we talked about sirtuins and how that supports NAD in the relationship, and CD38. Then you also talked about how it has to be recycled, and the recycling enzymes tend to get weaker as we get older. By the way, the gene site that I showed you tests for those enzymes as well. So if someone has sort of an inherent weakened ability, I always tell them there's no bad news. It just means that it's not working at full capacity, and we know where some of the hiccups are, or the weak links in the chain are, to be able to support that. Be interesting to see with any of your research people that may not have had the same outcomes, or may have been a little bit of the outliers if they did have those weaknesses. But anyways, with that being said, what I find to be very difficult is we talk about the balancing of mTOR and autophagy. Right. And maybe you can talk to the listener of what that actually is and how that relates to cellular aging and NAD. But what I find is difficult is how do you drive with your foot on the gas and the accelerate and the brake at the same time? Meaning, is there a research method, or is there a way to figure out that might be different from person to person, when they should be focused more on rebuilding, repairing, generating growth-like factors that are there every day, all day? But I think environmentally, even just with iron, EMFs, insulin, glyphosates, histamines, all of those things are very mTOR stimulating, that I feel like we never get a break from it. And we really are important to be able to turn on our sirtuins and our autophagy factors so that we get a break. I guess the long-winded question is, have you seen any research, or is there a specific way to implement strategies that are designed for repair processing or autophagy and clearing out versus full-on growth-like factors? Have you seen anything done with what you're doing, or does your recommendations consider that? Or I guess I would love to hear your insight on that.
Yeah. So I think what's important to note is that when it comes to aging, it's probably one of the most complicated things that we know in terms of biology. If you were to look at, obviously I've simplified it quite a lot and said there are 12 hallmarks of aging. There are 12 things that go wrong in our cells. But actually, if you were then to look at each of those 12 things and look at everything that's influencing them, then everything that's influencing them, you would end up with a huge, huge network that has thousands of different genes and proteins and pathways in it that are all interlinked, and they're all influencing each other. So when it comes to the hallmarks of aging, everything is interlinked. There is nothing that is standalone. And although we focus today a lot on NAD, just because, that's a topic that we're interested in, actually it's you can't just, boost your NAD and think that's going to be the be all and end all of it. Like you say, you've got to factor in a lot of the other areas like mTOR, AMPK, all of the other things that are going on, senescence, they're all having an impact. Not one single thing will fix the aging process. That is never going to happen. So when you mention things like balancing between building and repairing and protecting the sort of the mTOR pathway, things like that, the best way that I find to explain to people about this is to kind of get people to think about why we age in the first place. Because a lot of people don't understand that. They don't understand that, they think aging is just this natural thing, and it's like it's programmed, and there's nothing we can do about it. But actually, aging is quite a new thing in terms of the human race. It's quite a new phenomena, and this is because we never used to live long enough for aging to ever become a problem. And the reason for this is because we are, as a species, essentially designed to, be born and have a life purpose of reproducing, passing on our DNA to the offspring. And then as far as our biology is concerned, that is our job done. And this is called the disposable soma theory of aging, which is basically that our body is a shell to protect our DNA, to make sure that we pass it on to the next generation, which seems incredibly crude. But as far as evolution is concerned, that is what we're designed for. So evolution has done a very, very good job at optimizing our bodies, at being very good at being young. And this is because up until about 200-300 years ago, our average life expectancy was around age 40. We never lived till age 80. So everything in terms of our biology is designed to be very good at living up to around this age, which by no coincidence is just past childbearing age. And then that's it. Because why would evolution do a good job at optimizing our biology to be good at being old when we never ever reached old? Therefore, none of the traits that would make us be good at being old were ever selected for. So what this means is that we have a lot of pathways in our bodies that are very good at keeping us at being young. But think about what our lifestyles were like when evolution designed us in this way. We were hunter-gatherers. We were going for long periods without food. We definitely weren't eating 3 meals a day with a snack in between like we're promoted to. We definitely weren't sitting at computers. We were a lot more active. So what our biology is designed for is this way of life. So what you see is that a lot of the beneficial pathways that are involved in things like repair and autophagy, recycling, and cellular health only get activated in times of cellular stress. So in times when there's we're deprived of nutrients, or we are exercising really hard, this is when things like autophagy, the sirtuins, NAD, all of these things suddenly spring into action. When we are sat at a desk all day, not doing anything and eating, none of these pathways get activated, right? And that's because as a modern human, we're now living a completely different lifestyle to what our genes and our biology was designed to do. So for me, the best way to really start activating some of those cellular pathways that are involved in repair and autophagy and things that are known to be associated with good cellular health is to go back to how we're designed to be, which is introducing periods of fasting to actually switch on these pathways. Because what I always say is that our bodies are very, very good at looking after their cells. It just gets switched off. And you just need to switch it back on. These pathways are not lost, they're just switched off. So fasting is a great one. Exercise, and high intensity exercise as well as endurance exercise is all very good ways to activate a lot of pathways. And guess what? A lot of these processes, these lifestyle processes, work by actually increasing NAD.
Yeah, I love the answer. I give that a lot to the people that I work with as well when I do these genomic interpretations, especially like you said, like think about how we were designed over the millennia and how much we've deviated from that. And I even find now, Nichola, maybe you could agree or not, that some of these more favorable genes that got turned on or turned off or were passed down are now less favorable, obviously, because of our environment, what we've introduced into the environment. Now I see that a lot of people that we work with, they have major issues with recycling their iron, and NADPH is a major coenzyme that's needed for that process. And just like NAD, the environmental triggers with glyphosates and fortification and synthetic natures, EMFs. I mean, I hate to say that the sky is falling, but a lot of these environmental triggers turn on those genes that were evolutionarily favorable in the past, and now they're not. I mean, have you seen that as well, or have you kind of?
So a very classic example of this is senescence. So we know, senescence, for people that haven't heard of it before, is a process whereby if we accumulate so much damage in our cells to the point where it can't be repaired, our cells trigger like an alarm bell that says, oh my goodness, we have to stop this cell from replicating, and basically shut it down. And rather than recycling and getting rid of the cell, what happens is the body just puts it to sleep. So often these are referred to as zombie cells because they're not dead, they're just sort of sleeping and like in a trance, but they remain in the body. And when we're young, this was a very good way that evolution designed to stop us from getting cancer, essentially. It meant that if too much DNA damage accumulated in a cell, which could then become cancerous and replicate uncontrolled, this was a way of very quickly nipping it in the bud and getting rid of that cell while putting it to sleep. But now that we are living long, what happens is these cells accumulate in our bodies, which, hundreds of years ago would never happen because we never lived long enough for these cells to accumulate, but now we are. So this is something called antagonistic pleiotrophy, where it's something that our evolution has designed, which is beneficial when we're young, but then becomes an issue as we get older. Because, again, it was never selected to help us live longer. It was selected to help us get to childbearing age, and then that was our job done. But now these senescent cells are sitting in our bodies, secreting inflammation. They're taking up space. So it's estimated that around 30% of our tissues and organs as we get older are comprised of senescent cells, which is why you see in older people, they get heart failure and, organ failure. The skin loses its elasticity because all of these cells are sitting there taking up room, but not performing the function that they should be.
Yeah, you see that with the brown spots, or what they call the liver spots. Yeah, no, that's excellent. I love that the way that it's headed now. It's not just here's the product and take it, but we're doing research-based clinical trials to determine exactly what the outcomes that we're looking for, validating it, having these variables that you're manipulating and actually proving that it's there. But more so of what we just said in terms of, well, it's not a magic bean and you have Jack at the end of the beanstalk with a pot of gold. You actually have to fast and move and get outside with nature and really do the things that are free in life that you don't need to have a PhD to understand. So awesome. So the product's name is Time Plus, and you've been fortunate or you're kind enough to do a discount, and I've put it as Dr. Joel 20. Where do they go to check out the product?
Yeah, if you want to learn more about the product, you go to our website, which is nuchido.com, which is spelled NUCHIDO.com. I'm sure you'll pop that in the notes. But yeah, and we've got all the information about our clinical trial results on there, all the different ingredients in the product and what they're targeting and how they work. And yeah, I'm a huge advocate of education. I think it's very important for people to learn about all this science. So you'll also find a huge resource of lots of different blog articles all about aging well, I guess.
Yeah, no, that's awesome. So I have two more questions, and I'll let you go. I appreciate your time. And the first one, I'm putting you on the spot because I told you beforehand that I wanted to get your DNA and be able to run it. And maybe we can do a part 2 and get your insight with my insight as to how this fits into your research and what I teach people about these factors that ultimately are the perfect storm that could either preserve your NAD or looking at it as a demand and supply. These are the things that demand its production.
Yeah.
These are the things that supply its production. And we find that, you have a surplus or a deficit, and these are the things you could work on. So the first question is, what's next in the research for Nuchido? Is any interesting things coming down the pike?
Yes. So, I am still an active scientist. I have a lab which I manage, and I have PhD students which I train. We do a lot of active research. We're currently very focused on senescence, which is exactly what I've just been talking about. Senescence and NAD actually go hand in hand. It's thought that a lot of the inflammation that degrades NAD is actually coming from senescent cells, and equally low NAD can then cause senescence because lack of repair causes senescent cells. So it's like a vicious cycle. So yeah, senescence is a really key area that we're working on at the moment, and that's probably an indicator of what may be on the horizon.
Awesome. Okay. And then lastly, which I mentioned earlier, is that knowing what you know now, Nichola, in terms of health and longevity and things that you can do proactively, I guess the question is, what would you have told the younger self that may not have been privy to that information, that might have helped you along in any journeys, challenges, or that you may have had along the way?
I just think it's just incredibly important to understand your own biology. And I think I tell this to everyone now, because I guess when I started out in this field, it wasn't something that was available to consumers. So, like some of the tests we've been talking about, like genetic tests, biological age tests, the blood testing. I think it's just so important to get a good snapshot of your biology when you feel good, so that when things start to slip and you think, okay, I'm not feeling great, you know what all of your biology is and your biomarkers and your numbers are when you are good. Because otherwise you end up in a situation where you go to the doctor and go, I don't feel good. And the doctor goes, oh, we'll take your bloods. Oh, well, they're within average, as you were talking about earlier. And then, you're like, well, I don't feel good, so something must be wrong. But unfortunately, we're not average. We're not, we are all individuals. I believe in the future that when, every child is born, they'll have the genetics done. They'll know exactly what they are going to respond to in terms of lifestyle, in terms of drugs, in terms of, a lot of different things, what their risk factors are, things they need to be careful with. The future will be personalized, but we're not there yet. But consumers do have access to things that can start them off on that journey now.
Yeah, no, awesome. And I find obviously with AI how accelerated the learning curve really is. It's quite amazing. But yeah, you shared amazing information today. I appreciate your time. There's definitely a lot more I could ask you, but I wanted to keep it brief. And I think we gave a great overview of it. I appreciate everything that you do. And I look forward to potentially doing a part 2 with a review of what you send me. And I wish you for nothing but future success in everything that you do.
Thank you so much. And likewise, thank you so much for having me on. And I definitely look forward to digging into my DNA and having a bit of a geek out about that.
Perfect. All right. I look forward to it. Hi, thank you so much for watching our Age Reversing Blueprint podcast. If you've made it this far, we sincerely thank you for your attention and your interest in reversing your age. If you're looking to get more information on today's topic or other podcasts that we've had, be sure to check out the show notes and be sure to check out drjoelrosen.com. Have an awesome day.